Okay, now let us see the different types of biogas plants which is currently available or making use of. So biogas digesters are designed to increase or facilitate the anaerobic digestion process. Common types include fixed dome digesters, floating drum digesters, plug flow digesters, and batch digesters. So all those four we'll see in this particular class video. Only introducing it. We are not going in depth of the how they built and what are the materials used and what exactly the terms and all. We are not going introduction only. What are the different types are there that we are seeing. Okay, so we can see fixed dome digester. Here everything is fixed, made with bricks. Everything you can see is something which is fixed, and the dome. You know what is dome? Dome of this particular structure called as dome. So the dome structure it is fixed, therefore fixed case. Then here it comes the name floating drum digester. So you can see this is the drum. This is it can float. It can come down, it can go up as the water present or the content present in that. If it decreases, it will come down, or if the gas pressure pushes it, it goes up. So we have the floating drum case. And there are plug flow, just like step by step movement of the food waste. Finally, it is getting converted into gaseous form. There is a screw for the rotation. The whatever input given through the screw type when it rotates, it reaches the end, and the different reaction, biochemical reaction takes place in between that, and the gas is connected. That is plug flow. And finally, that is the batch digesters. Batch digesters, one step by step. Sometimes for few times it is kept in first container. After that, it is transferred to a second one. Then after some time, third one. Then after that, containing into last one. And the whatever gas formed it is used. That is batch type. Okay, so these are the four different types of uh, biogas digesters. Roughly, you need to draw the diagram. For example, if it asked, at least you should remember the names: fixed dome digester consists of fixed non-movable dome and a digester tank. They are simple, they are durable and relatively low cost. There is a tank to supply the waste food mixing tank. Then it is taken to the inside that one. There the biochemical reaction takes place. Gas will be formed. Gas will be taken out from using a gas valve, and whatever the waste after digestion, the waste will be, it will be by default pushed to another chamber. From there it has to be taken out. Second one, that is floating drum digester. They have a movable gas holder that arises and falls with gas production. So they allow easy measurement of gas yield but are more expensive and require more maintenance. Okay, so once if the drum meter moves up, that in itself indicates that there is a gas generation inside that. And if the drum is going down, that means that the production of gas is less. Therefore, we'll get an indication, or we can measure how much yield we are getting by seeing the movement of drum is. But making such type of moving drums and all, it is a little bit more expensive and more maintenance required. Okay, the remaining things are almost the same. There is a mixing tank where the waste it is mixed, and then it is taken inside. There the reaction takes place, and whatever waste it will be, by default with the pressure it will be pumped out or taken out. Then plugged flow, it is suitable for a high solid content. These digesters have a long, narrow tank where the biomass moves in a plug flow manner. So it moves, it make it to rotate, keep on rotating, pushes that one. Therefore, a mixing takes place, crushing takes place, and even the biological reaction also takes place. Gas is formed, and the remaining sludge it is removed from that. Okay, so by seeing this image you will get the idea of that. Then batch digester operate in a batches rather than continuously. It is suitable for small scale applications. Now the gas yield, I'll continue as part of this video. The gas yield from biogas digest depends upon several factors. Whatever feedback composition we have, the type and quality of the material used, the waste material used to get biogas. We don't want to put our food as such to the this one. After the waste material has to be used, therefore its composition is one of the criteria. Digestion temperature, if it is 20 to 45 degrees Celsius, we call it as mesophilic. If it is 45 to 60 degrees Celsius, it is thermophilic. These conditions, it will affect the microbial activity and gas production rate, because once it reacts, there is some chemical reaction happening. Even though it is using the microorganisms, sometimes the temperature goes up to 60 degrees Celsius, and some microorganisms at that temperature it cannot survive. Therefore that will affect, and some microorganisms they need some particular temperature to be active. So that also, so you can say that biogas production, it also depends upon the digestion temperature. Retention time, the amount of time the material remains in the digester, that is the retention time. How much time we are keeping the uh, material inside for the digestion, that is also depends on the gas yield, or gas yield depending on that. Called as retention time. The level of pH, approximately almost neutral pH. Neutral pH is exact 7, 6.8 to 7.2. That pH it is needed for an anaerobic digestion. Characteristics of biogas, it primarily consists of methane, 75% up to, then 20 to 25 to 50% carbon dioxide, then the remaining hydrogen sulfide and nitrogen, all those also will be there in the biogas which is generated. So the combustion characteristics are high heating value, clean burning, flammability. Due to the high methane content, the biogas, it has got a significant calorific value. Calorific value means how much energy is inside in that which gives the conversion to heat. How much heat we are generating from a fuel, we call it as calorific value. Then we have, it is a clean burning. There is no much pollution from biogas plants. Uh, Gaseous pollutants are not there compared to the other fossil fuel burning the wood, or other burning the gas as such naturally. There more pollution is there, but as here biogas plant, the pollutant pollution is very less, or it is a clean burning. There is no formation of pollutants. Methane, it is highly flammable. It will catch fire easily. That is the meaning of flammable. It can catch the flame easily. That is therefore the name flammable. It requiring careful handling and proper ventilation. Because of it is more than flammable. Also, we have to be very careful because it will catch fire very easily. Then utilization of this biogas plants, where and all it is used. It is used in normal cooking. Biogas stoves are designed to utilize methane or household cooking, providing a clean and efficient fuel alternative to wood charcoal. In our institution also, we have the biogas plant in our canteen. People who are not seen can go and visit it. We are generating the biogas, and using it for some cooking work. Then power generation, biogas can be used in internal combustion engine or gas turbines to generate electricity. It can also be upgraded to biomethane. Biomethane to uh, and injected into the natural gas grid. Okay, so it can be integrated. The biogas plant can be integrated to the natural gas plant, natural gas stores, bio, what is called the earth. From the earth itself, we are getting natural gases. That generation to that grid, it can be connected. Heating, biogas can be used in boilers for space and water heating, offering a a sustainable alternative to conventional heating fuels. So that's about biogas and biogas types and related topics. Next, geothermal energy is entirely different one. Separate video I will take.